Often in MATLAB we do a series of symbolic manipulations of some sort of expression, and then in the end we want to put in some numbers, and we might need to put those numbers into more than one variable, so do more than one substitution. And often what we want is just a decimal approximation of the actual answer. So let's do that. Okay, let's start by opening up a new script, and we'll clear everything out of memory, close everything, and put a line in to clear the command window out for us, and then we'll start. Okay, so let's imagine we have some function we'll call z, and we'll say z is a function of x and y, so maybe it's something like that. And we have to, if we're going to work symbolically, we have to tell MATLAB that these are symbolic variables, so we need the sim statement at the very start. So let's have a couple of variables. Let's have x and y be our variables that make up our function. And let's make this a little more interesting. Let's have it something like x plus y to the fourth, or something like that. Okay, so we have some function. Great. And now let's do two things with this. Let's take the derivative of this. Let's do a partial derivative with respect to y. And after we take that partial derivative, let's substitute numbers in for x and y and see what the value of that derivative is. Okay, so we say that let's come up with a derivative. Let's give it the name g. Let's say that g is equal to the partial derivative of z with respect to y. Okay, so we could run this script. If we run it now, let's give it a name. We see that it takes our function and takes the derivative of it. Now let's say we wanted a numerical value for g at certain values of x and y. We can put that in by using the substatement. And let's have the result be something called h. Let's substitute in to z the numbers. And notice that we have to get a numerical value for h, we're going to need to put in we're going to need to substitute into x and to y. So we have to have a list. So we're going to say the list of variables that we want to substitute into are there, and then we have a separate list in braces. So we're using those curly braces for the numbers we're going to put in. So we're putting into x, let's say that x is equal to 10 and y is equal to 5. Now we have a substatement where we're saying take this function z. Actually, we wanted to put this into the partial derivative g. So we're going to take this partial derivative g, and we're going to find out its numerical value by putting these numbers into those variables. Very good. So we run that. Okay, and we run that. Notice that what we get is the exact answer, but oftentimes the exact answer is not what we want. Often we want a decimal approximation. Okay, and so we have to tell MATLAB that we want an approximation and not the exact answer. And the best way to do that is with a double statement, which gives you a double precision number in place of the actual answer. So we were saying, no, we don't want the actual value of h, not the perfectly accurate answer for h. We want a decimal approximation. So we're going to say we want a double h, run that, and it gives us the decimal approximation. So this is a decimal approximation for the actual answer there. So using these tricks, we can substitute into multivariable function and also get a decimal approximation out as our final answer.